The question on this reflection for lesson 1.3 that you just did was involving determining what digit is the prime number. So if you take a look at the list numbers that I have here are the list of numbers that you had in the question. Say 1, 2, 15, 21, 27. So in order to answer this question correctly, you need to first have a clear understanding of what a prime number is. So let's take a look at that definition. So if we look back at our textbook page, look in the middle of this page here, it says prime numbers are numbers greater than 1 with exactly two distinct factors, 1 and the number itself. So let's reread that again. Prime numbers are numbers greater than 1 with exactly two distinct factors, 1 and the number itself. So that means that the only numbers that you can divide that particular number by are 1 and itself. So for example, 11 is a prime number because 11 can only be divided evenly by 11 and 1. Whereas composite numbers are numbers that have more than two distinct factors. So 10 would be a perfect example. Yes, it's divisible by 1 and 10, but it's also divisible by 2 and 5 as well. So 10 would be a composite number. If we look back at the list of numbers, we can use our definitions to help us determine which one or ones would be the prime number. So let's start with 1. 1's only factors are 1 and itself, which is 1. Okay, that's the only way you can multiply two numbers together to get 1. Whereas 2 has 2 times 1. There's no other way to multiply two numbers together to get 2, or divide 2 by any two numbers. So we'll come back to that one as well. 15, you have 5 times 3, but you also have 1 multiplied by 15. So 15 is divisible by 5, it's divisible by 3, it's divisible by 1, and it's also divisible by 15. 21 is divisible by 3, because 3 times 7 equals 21. It's also divisible by 1 and 21, because 1 times 21 equals 21. And then 27 is divisible by 3 and 9, because 3 times 9 equals 27. It's also divisible by 1 and 27. So again, if we look back at our definition, prime numbers are numbers greater than 1 with exactly two distinct factors, 1 and the number itself. So do we have numbers that are greater than 1? Absolutely, they're all greater than 1. Do we have numbers with exactly two distinct factors, 1 and the number itself? If we look at this, the only one that meets those requirements is the number 2. Its only factors are 1 and the number itself, which is 2. Whereas 1, on the other hand, it's not a prime number because it doesn't meet those requirements. Its factors are just 1. It only has one factor. It doesn't have two factors, which prime numbers have. So 1 is called something else, and we talked about this in our text as well. It's called the multiplicative, and I might run out of room to write this, multiplicative identity. Okay. And that's because when you multiply any number by 1, the product is the number itself. So when we multiply 2 by 1, the product is 2. We multiply 15 by 1, the product is 15. So hopefully that helped you figure out that problem. Remember, prime numbers, only one distinct factor pair. the number and 1. Okay. Thanks for watching. Hope you learned a lot.